A very good evening. Am I audible? A very good evening, sir.
Good evening, sir. Am I audible?
Yes, sir. Audible, sir.
Okay, that's good.
A warm welcome and very good evening to all dear participants. Resource person of today's session, our respected Dr. Dushyant Tyagi, sir. Today we are having one more lecture on Excel. This is a practical session. Now I would like to introduce sir. Few participants are not presented in last class. Sir is currently working as assistant professor in the Department of Mathematics and Statistics at Dr. Shakuntala Misra, National Rehabilitation University, Lucknow. Sir possesses 11 years of experience of educating in various institutions of repute like GB Pant University of Agriculture and Technology, Institute of Technology and Science, Ghaziabad, International College of Financial Planning, New Delhi, and Lady Sri Ram College for Women, New Delhi. His research area is statistical quality control and computational statistics. Sir had the responsibility of convener and resource person for 3 AICTE-sponsored faculty development program on advanced data analysis through data analysis softwares. Sir delivered lectures in more than 25 research methodology workshops. Sir has 6 research paper publications in reputed international journals and 1 book. Sir has presented his research work in various national and international conferences and attended several seminars and faculty development programs of statistics and related areas. Sir was associated with the many government and private universities, institutions as visiting faculty. Now, I again invited Sir, please lead today's session. Please, Sir, welcome, Sir.
Thanks, Amitji, and thanks to all organizations team. Uh, a very good evening to all the participants. I hope you all are fine and enjoying the learning, a long learning of research methodology and data analysis tools. Data analysis. Good. So, in last class, that is scheduled on Saturday, we have discussed about basic of statistics based data entry on Excel, then descriptive statistics with the help of Excel, then correlation, regression, graph, how to make a frequency distribution with the help of raw data, how to make the discrete frequency distribution, continuous frequency distribution, pie chart, bar chart. We have discussed basics, all these basics on Saturday. So I hope that you all have tried all these things. And if there any problem, you may ask in the chat box. So today we have to discuss, I plan to discuss regression analysis and testing of hypothesis. So we will deal with the same data. We work same data. 1 minute. Let me share my screen. Is my screen visible to you?
Yes, sir, visible now.
Okay, thanks. So this is the same data set which we have discussed on Saturday in last session. The name is there, gender, location, age, height, weight, BMI, duration, VO2 maximum heart rate, duration 1, VO2 maximum 1 and heart rate 1. That means a normal person done exercise on the treadmill and how much, what's the age of the respondent, what's the height, weight. So with the help of height and weight, we have calculated BMI. Duration is there, at how much duration he or she has done the exercise, then VO2 maximum level, heart rates, and so on. This is, we can say, in morning, and this is in evening. So we have discussed how to make the frequency distribution with this or summarize the data. That means when we are dealing with univariate data, but when we are doing bivariate data, we have discussed correlation. If the correlation coefficient is R is, we can say, 0.8. So what interpretation you can give with the help of correlation coefficient 0.8? if there is correlation coefficient between VO2 maximum and weight is 0.8, आप क्या interpretation कर पाएंगे उससे? Any one of you, please raise your hand. I request the organizer to unmute the person who will raise their hand.
Yes, sir. Sure, sir.
Please tell me what's your interpretation in that case. If the correlation coefficient is 0.8 between two variables, I want some interactive session, both side discussion, not one side input only.
I request all participants, please raise your hand so I can send you the unmute request.
Correlation coefficient in last session we have discussed that correlation coefficient range is -1 to +1, and if the
Hello, sir.
yes,
Then it is positively correlated.
that it is positive, highly positive correlated. That means those two variables are highly positive correlated. Absolutely correct. Good. They are highly positive. That means with the help of correlation coefficient, we calculate the degree of associationship between two variables. But when we are calculating correlation coefficient, we don't say that this is dependent variable and this is independent variable. So if the two variables or more than two variables are correlated to each other, to use this associationship, use this dependency, we fit a model, and that model is known as regression model. So to fit a regression model, we assume one variable as dependent variable and one or more than one variables as independent variable. That means the dependent variable is depending on independent variables. So if it is single variable which is independent, and it is known as simple regression equation, a simple regression model, and if it is more than one variable, it is known as multiple regression model. So here we may assume that we are having the data set. We don't know that these variables, the age, height, weight, BMI, duration, VO2 maximum, heart rate, and these are depending on each other or not. So we want to check that is the heart rate is depending on age, height, weight, BMI or not, or duration. Okay. So if we want to check this, if we want to fit the regression model on this, then the regression model becomes that heart rates equal to beta naught plus beta 1 age plus beta 2 height plus beta 3 weight plus beta 4 BMI plus beta 5 duration, beta 6 VO2 maximum. If we are including VO2 maximum, then it will. So to fit the regression model with the help of this data set, assuming that heart rate as dependent variable and age, height, weight, and BMI and duration as independent variable, what we have to do, we have to click on data. After clicking on data, you will see data analysis tool pack is there. So click on data analysis. You will get this drop down dialog box. And in this regression, yes, regression option is there. Click OK. Here, what is input Y range, input X range? Y means dependent variable and X means independent variable. So here we are assuming that heart rate we will take as dependent variable and X, age, height, weight, BMI as independent variable. Duration, we may take duration also. Okay. Now, is in the first row label is there? Yes, label is there. So we will click on this checkbox. Then output we want on new work plan. Residuals. Initially, we are not plotting any residual plot here. So click on OK. is from 45. The number of variable and the number of observation in the independent variable should be equal to the number of observation in the dependent variable. One minute. Some problem in input range. Regression, okay. Then input range for this is heart rate for then input range for is axis from age to duration. Okay, one value is missing in duration. I'm writing here hypothetical value. Data analysis, regression. This is this. So here you got the result. This is summary output. That means multiple R, multiple correlation coefficient is 0.58. That means correlation coefficient between these all 5 or 6 variables is 0.58. The R square. Who will tell me the interpretation of R square or adjusted R square? Because this we have already discussed in previous lectures. Any one of you? Please. Interpretation of R square and adjusted R square. When we are doing any regression model, fitting any regression model, the interpretation is very important. R square is, we can say, coefficient of determination. That means how much percent variation in dependent variable can be explained by the variation in independent variable. That is, if R square is 0.33, so we can say 33% variation in dependent variable, that means heart rate, depends on the variation in age, height, weight, BMI and duration. But as we increase the number of independent variable, R square increases. So adjusting that increase of R square due to the multicollinearity in this all the variables and all other factors, due to the increase in the number of independent variable, we interpret or we take adjusted R square as the coefficient of determination. And we now for this model we can say that 24.9% variation in heart rate depends on age, height, weight, and BMI and duration. Clear? Now the ANOVA, you will get the ANOVA table in there. In ANOVA table, we are calculating the F value and significant value. So F value is here in the ANOVA table, we are testing the overall null hypothesis. What is overall null hypothesis? That means here we are testing the hypothesis H naught. H naught, that all beta i's are equal to 0. That means none of the independent variable is contributing in the मॉडल मॉडल में कोई भी इंडिपेंडेंट वेरिएबल कुछ भी कंट्रीब्यूट सिग्निफिक कोई भी सिग्निफिकेंट कंट्रीब्यूशन नहीं है मॉडल के लिए ऑन व्हाट इज H1 here that at least one beta I is not equal to 0. That means if this null hypothesis is rejected, that means कम से कम एक बीटा आई तो मॉडल में, यानी कि एक इंडिपेंडेंट वेरिएबल तो मॉडल में बहुत अच्छा कंट्रीब्यूशन कर रहा है, सिग्निफिकेंट कंट्रीब्यूशन कर रहा है. So this we get with the help of analysis of variance. So in the analysis of variance with the help of f value or p value, we are testing this null hypothesis that all beta I is equal to 0, where I equals to 1 to 5. So here the f value is 3.8553 and the significance value is this. So we have to reject or either we will reject this null hypothesis or we will say that we have failed to reject the null hypothesis on the basis of decision rule. What is the decision rule here? That reject H naught if calculated F is greater than right here capital F. F at greater than F degree of freedom of numerator, degree of freedom of denominator. Here the what's the degree of freedom of numerator and denominator? The numerator degree of freedom is 5 and denominator degree of freedom is 38. That means 5 comma 38 comma degree of freedom, that is 0.05. So either if calculated F is greater than this value, then we reject the null hypothesis, or your you may decide about the null rejecting of the null hypothesis on the p value also. If your p value is greater than if your p value is lesser than level of significance. So here we have taken the level of significance 5%, that is 0.05. Okay. So here your p value is 0.0063, which is lesser than 0.05. That means we may reject the null hypothesis. And to calculate the table value of f statistics, we may use the Excel, that is equals to f dot distribution, and we want the probability of right side. So right tail equals to the value of x is this, comma degree of freedom of numerator, that is 5, comma degree of freedom of denominator, that is 38. Okay, this is the significance value we received, we calculated here. If we want to calculate the f value, that means the p value, the probability after this point. If we want to calculate the p value, f value here, then f dot inverse dot rt, then probability. How much probability we are checking right side? 0.05. Degree of freedom 1, that means numerator degree of freedom is 5 and denominator degree of freedom is 38. So the table value of f is 2.46 and our calculated value of 3.85 is greater than this. So we may reject the null hypothesis. If we are rejecting the null hypothesis, then we can say that all beta I are not equal to 0. Any one or more than one, at least one beta I is significant. So the model is good fitted. Now these values, these are telling you the values of beta naught, that means intercept, beta 1, beta 2, beta 3, beta 4 and beta 5. So your model becomes heart rates equals to 189.88 plus Oh, not plus, because the age coefficient is minus, so we'll write minus 0.5328 age plus 0.094 height plus minus 0.2836 weight plus 0.4363 BMI and plus 0.0076 duration. So this is the regression model. And what is the interpretation of these values? That means if the age will increase by 1 unit, then keeping all other variable constant, then the heart rate will be decreased by 0.53 units. If height will increase by 1 unit, keeping all other variable constant, then heart rate will be increased by 0.094 units and so on. So in this way, we may interpret these values. Now, to check that individually which independent variable is contributing to the model, we have to check this t value and this p value. So if we will have to check that which p value is lesser than level of significance. So this first one on age, it is lesser than significant, that is 0.007572. So we can say all others are greater than level of significance, that means 0.05. That means we can say that only and only age is contributing significant in this model. Clear? जो केवल एज वेरिएबल है वो मॉडल में कंट्रीब्यूट कर रहा है significantly. All other variables are not contributing in the model. Yeah. Because here the p values are greater than 0.05. That means this is the only significant, this variable is only significantly contributing to the model. All others are not contributing to the model. So here the R square is adjusted R square is 0.24. Now what we will do, we will make another model where we will take only the age and age and heart rate is independent variable and age and dependent variable. Data analysis, regression, okay. So here heart rate is this and the independent variable become dependent variables if we are taking only the age. Here so adjusted square is 0.30, that means increased, and your f value is also increased. Here f value is also increased, and it is saying that the model is highly good fitted, and this p value is also decreased. Now what we'll do, we will take only those variables which are not contributing in the model. See what happened there. In data analysis, when you do the different thing, that means on the same data we apply, you fit the model with the taking the different variables, so you will get more. Age, height, weight, and no, not age, height, weight, and BMI. If we are taking these variables, then okay. So this is your model. So here your f value is 0.83 and your p value is 0.48, which is greater than level of significance. So you can say that the model is not good fitted. None of the independent variable is contributing to the model. Or you can check here also. For all independent variable, the p value is greater than level of significance. Got it? So this is regression model, and before fitting the regression model, you have to also check that is the observations are normally distributed. is the residuals follow normal distribution with mean 0 and variance, fixed variance. That means the data, the error should be homoscedasticity. There should be the error should not auto correlated. So there are some assumptions for regression model. So before applying the regression model regression model to the data, you should check the main assumptions, 6 or 7 main assumptions of the data before applying the regression model. क्लियर? आपके जो इंडिपेंडेंट वेरिएबल्स हैं वो हाँ, इंडिपेंडेंट वेरिएबल्स इंडिपेंडेंट होने चाहिए, आपस में सिग्निफिकेंट कोरिलेशन नहीं होना चाहिए, नॉर्मली डिस्ट्रीब्यूटेड होना चाहिए डेटा, एरर नॉर्मली डिस्ट्रीब्यूटेड होनी चाहिए. These should be checked before applying the regression model for any forecasting. Now after regression analysis, the next is that sometimes we have to compare the values before and after. That means before treatment, the VO2 maximum, and after treatment. So these values are before treatment and these values are after treatment. This is morning, in between they have taken some treatment, and then after treatment values are there. So if we have to compare the values before treatment and after treatment, then we will use the paired sample t-test. Paired sample t-test. When we use the paired sample t-test, when the populations are related, that means on same population we are applying, we are calculating the data 2 times, before, after, before event, after event. If we are calculating the data, if we want to check that is this particular treatment, a particular medicine is effective or not, so the data, or we can say the reports before treatment and after treatment, we have to compare that is there significant change due to this event. So here we will apply t-test paired 2 sample for mean. That means we are comparing the mean of 2 population with the help of paired t-test. Then okay. Now here the variable 1 we can say that VO2 maximum before treatment, and then variable 2 is VO2 maximum after treatment. See here the first variable is J1 to 45 and the second variable is M1 to 45. In first row there is labels are there, and okay. So these are the values, these are the results. The mean of before treatment of VO2 maximum is 40.56 and after treatment is 42.18. The variance is given here. So in both the cases, the observation are 44, and it is the condition that for pair t-test, in both the samples, the observation should be, number of observations should be same. Pearson correlation coefficient is 0.96. That means Karl Pearson correlation coefficient is 0.96. That is a highly positively correlated. And the t value is minus 4.35565. So here also the null hypothesis that H naught. Here in this case, the null hypothesis is H naught mean before is equal to mean after. Here we have the population mean we denoted by mu. H1 mean before is equal to mu after. Not equal to. In null hypothesis means equal. In equal to sign we always put in null hypothesis, and in not equal to sign we always put in alternate hypothesis. Alternate hypothesis may be less than equal to or may be greater than equal to, and if the alternate hypothesis is less than equal to, then the null hypothesis become greater than equal to. So here the for two-tail, because this our test is two-tail test. This test is two-tail test. Here the critical region will lie on both the side. So we will check the p-value of two-tailed. The p-value of two-tailed is 8.08 multiplied by 10 की power minus 5. 10 की power minus 5. That means the value becomes 0.000080. That means it is less than level of significance 0.05. So we may say that the p-value is less than the level of significance. So we may reject the null hypothesis. So आप null hypothesis को reject कर सकते हैं, and we may say that the difference is significant. जो VO2 मैक्सिमम है और VO2 मैक्सिमम 1 है, उनके दोनों के मीन में सिग्निफिकेंट डिफरेंस है. दैट मीन्स जो ट्रीटमेंट बीच में दिया है वो सिग्निफिकेंट है. Got it? Is any confusion in this? आप मेडिकल लाइन में बहुत बार ये आप टेस्ट यूज करते हैं, पेयर टी टेस्ट. इज द इवेंट इज जरूरी नहीं है कि आपका जो सैंपल रेस्पोंडेंट है वो सेम ही हो एग्जैक्टली, लेकिन सेम पॉपुलेशन. दैट मीन्स 100 आपके पास टोटल पेशेंट है उस डिजीज के, और आपने उसमें से 20 का सैंपल लिया उस पूरे पूरे पॉपुलेशन 100 पॉपुलेशन में से. फिर आपने क्या किया, after giving the treatment, after treatment you have taken the 20 samples in the same population, then also you may apply this pair t test. Now after pair t test, if we have to compare that the mean duration on treadmill is same for female female and male candidates, ठीक है. That means मेल्स में और फीमेल्स में ड्यूरेशन सेम है. व्हाट वी हैव टू डू हियर, वी हैव टू सेपरेट दीज टू वैल्यूज. मेल और फीमेल्स की वैल्यूज को आपको थोड़ा सेपरेट करना होगा. These are the values for male and these are the values for female. So this here we will say the t-test for two sample assuming equal variance. That means we may assume that the variance is equal or variance is unequal in both the population. So to check that the variance is equal or not, we use the F-test. F-test to samples of variance. So first range of we are taking the duration. Duration for female and duration for male. Now first we are testing that is the variance between these two population is same or not. So here the null hypothesis that the variance is same. That means दोनों populations में variance same है. Okay, this is the null hypothesis. And what's the result says? The null hypothesis that the variance is same. So here mean for duration is same. 52 for females and for males 643. But and variance is there, and the F value is 1.5 and the p value is 0.37. 0.37 is greater than 0.05, that means level of significance. So we'll say that we are fails to reject the null hypothesis. That means आप null hypothesis को reject नहीं कर पा रहे हैं. That means we are accepting the null hypothesis. अगर ये p value 0.05 से कम होती तब हम कहते we are rejecting the null hypothesis. लेकिन ये p value आपकी 0.05 से greater है तब हम कहेंगे we are fails to reject the null hypothesis और we are accepting the null hypothesis. That means दोनों ही populations के मेल के जो ड्यूरेशन है और फीमेल का जो ड्यूरेशन है उनकी पॉपुलेशंस के जो वेरिएंस हैं वो इक्वल है. Now here we have tested the variance of both the population. Now we will test the mean of both the populations. So we will choose the t test for equal variance or unequal variance. Which option we will choose here? Reply on in chat box. Now which test we will apply here? two sample assuming equal variance or assuming unequal variance? Just now we have checked the variance. Equal variance. Absolutely correct, Dr. Sachin. Because just now we have checked the variance and we found that the variance of both the population is equal. So we will check the equal variance. Good, Dr. Prashant. Okay. Now variable, we will input the range of variable one, and the range of variable one is this. And we will input the range of variable two. I have taken a small data so you can understand it. And in your research, it may be a large data, no issue. So variable one is this, variable two is this. Label is there in both the cases. Now we are testing, applying the test two sample assuming equal variance. Okay. Here is the result. The means are this. And tell me, in this condition, if there two tail test is there, that means in H naught we are assuming that mean mu1 is equal to mu2. Here what we will say that H naught mu for female is equal to mu for male, mean for male, and H1 is that mu for female, mean for female is not equal to mean for male, mean duration for male. Now tell me, in this case, with the help of this value, we will reject the null hypothesis, or we will say we are fails to reject the null hypothesis. With the help of this result, what we will interpret? क्या conclusion लेंगे हम? Null hypothesis को आप reject करेंगे कि accept करेंगे? Reject. Dr. Harni is saying accept. One is saying reject. Sonam is some are saying reject and some are saying accept. See here the null p value is greater than level of significance. Level of significance we are assuming in maximum time we assume it is 0.05. So what we will say that we are not reject, Dr. Nidhi, not reject. We cannot reject at this time because here p value is greater than 0.05. जब अगर I told you ना, just now I told you in this case. आपका डिसीजन रूल क्या है? पी वैल्यू रिजेक्ट होने के लिए, टू रिजेक्ट द नल हाइपोथेसिस, टू रिजेक्ट एच नॉट, योर पी वैल्यू शुड बी लेसर देन 0.05. आपकी पी वैल्यू 0.05 से लेसर होनी चाहिए, और यहां पर क्या हो रहा है? आपकी पी वैल्यू ग्रेटर है 0.05 से. So you will say that we are fails to reject the null hypothesis, or you will say that we are accepting the null hypothesis. Reject नहीं कर पाएंगे. Yes, डॉक्टर प्रशांत एक्सेप्ट करेंगे. गुड, ठीक है. वी आर एक्सेप्टिंग द नल हाइपोथेसिस. नल हाइपोथेसिस क्या है हमारी? दैट बोथ द ड्यूरेशन फॉर मेल एंड फीमेल इज सेम. तो अगर सेम है और आप क्या कर रहे हैं एक्सेप्ट कर रहे हैं, तो यानी कि इसमें बहुत सारे सिग्निफिकेंट डिफरेंस नहीं है. ड्यूरेशन में सिग्निफिकेंट डिफरेंस नहीं है. अगर आप चेक करें VO2 मैक्सिमम चेक कर लेते हैं. फर्स्ट डेटा इज दिस, and in the second data VO2 maximum one is this. Okay, here also the value is greater than 0.05, so we will say that the VO2 maximum is also same for male and female. ठीक है. जब हम बिफोर एंड आफ्टर देख रहे थे तो VO2 मैक्सिमम सिग्निफिकेंट डिफरेंस आ रहा था, लेकिन मेल और फीमेल में सिग्निफिकेंट डिफरेंस नहीं है, यानी कि मेल में दैट मीन्स मेल में भी इफेक्टिव है और फीमेल में भी इफेक्टिव है। ये जो आपका ट्रीटमेंट है वो मेल और फीमेल दोनों में इफेक्टिव है, लेकिन ये ऐसा नहीं है कि मेल में ही इफेक्टिव और फीमेल में इफेक्टिव है, दोनों में इफेक्टिव। नाउ दिस इज व्हेन वी हैव टू कंपेयर टू पॉपुलेशन में। जब आपको टू पॉपुलेशन मीन्स को कंपेयर करना हो तब आप टी टेस्ट फॉर टू इंडिपेंडेंट सैंपल, टू सैंपल इंडिपेंडेंट सैंपल बोलते हैं। व्हाई वी आर सेइंग इंडिपेंडेंट सैंपल? क्योंकि मेल पॉपुलेशन इज डिफरेंट देन फीमेल पॉपुलेशन। व्हेन वी हैव टू कंपेयर द रिजल्ट्स फॉर टू डिस्ट्रिक्ट, दैट मीन्स द is the medicine is effective in hill station also as it is effective in plain. So when here we are comparing the plain location as to hill station location, so both the populations are different. So here we will apply two t test for two independent sample. Yeah. Now here we are having male female gender location. Location is there, and locations are three locations are there: urban, rural, and semi-urban or semi-urban. So when we have to compare the, if we want to compare the VO2 maximum level of different locations, that means is there is significant difference between the mean VO2 maximum level of urban, rural, and semi-urban. So here there are three populations. We are comparing the mean of three populations. So when we have to compare the mean of three population, that means three treatments. So which test we will apply? When we have to compare the mean of three population. Yes, absolutely correct, Dr. Akshay. We will apply ANOVA, analysis of variance. So to apply the analysis of variance with Excel, we have to put the values of these three in three different columns. Here we have, say, these are the rural background, these are from semi-urban, and these are from urban background. So what we will put, we say in one column we will put a rural observations from rural. In one column we will put semi-urban. In one column we will put urban. Okay. So we want to compare the VO2 maximum. So these observations from rural background, respondent, and these are from semi-urban, and these are from urban. Now here we click on data, we will click on data analysis, then we will click on ANOVA single factor, because here is single factor, that is rural. Or we can say location, factor is location, and this factor is at three levels: rural, semi-urban, and urban. Okay, input the range is this. Group, the labels are grouped in column, and in the first row the labels are there. Okay, so this results you get here. Here the null hypothesis that the mean VO2 maximum of rural is equal to the mean VO2 maximum from semi-urban is equal to mean VO2 maximum of urban. So here the summary is that 18 observation from rural background, 13 observation from semi-urban and 13 observation from urban background. Sum is there, average is there, and variance is there. Clear? So ANOVA table is this. Here the F value is 2.6. Now the P value is 0.08, just greater than 0.05. So we will say that if our level of significance is 0.5%, if we are our level of significance is 5%, because level of significance we have to specify the level of significance. So if we are specifying our level of significance 0.05, then we will say that we are fails to reject the null hypothesis. That means we are accepting the null hypothesis that the mean of the all the three population, all the three locations are same. But if we are able or agree to increase the level of significance from 5% to 9%, that means 0.09, then in that case we may reject the null hypothesis and we will say that the mean of VO2 maximum at three location is differs significantly. Got it? Getting my point or not? That means your p value tells you that this is the minimum level of significance at which you can reject the null hypothesis. अगर आप null level of significance को इतना increase कर पा रहे हैं, if you can increase the level of significance till this value, then you may reject the null hypothesis. Okay, so अगर बहुत ज्यादा होता है तब हम नहीं इतना इंक्रीज कर सकते, लेकिन 10% तक तो हम वी कैन से इफ द लेवल ऑफ सिग्निफिकेंस इज 10%, then we may reject the null hypothesis and we can say that the difference between the mean of the three locations is differs significantly. Got it? So this is the analysis of variance. So here we have discussed when we have to compare the population mean of related population. That means before and after samples, before and after population mean. When we have to compare the two population mean of independent population. Here it is when we have to compare the population mean of three populations, three different populations we are having, and we have to compare this. Or we can say when we have to compare the one factors with more than two labels. Okay. Now, if we have to check the association or dependency when the data is collected on ratio scale or interval scale, then we apply correlation coefficient. Then we calculate Karl Pearson correlation coefficient. जब हमारा डेटा रेशियो स्केल पर या इंटरवल स्केल पर होता है और आपको चेक करना हो इंडिपेंडेंसी और एसोसिएशन चेक करना है, तब आप कार्ल पियर्सन कोरिलेशन कोएफिशिएंट कैलकुलेट करते हैं. बट इफ आवर डेटा इज गिवन इन नॉमिनल स्केल, if our data is given in nominal scale or ordinal scale, and we have to check the association or we can say dependency of these two variables, that one variable is depending to other or not, one nominal variable is depending on other nominal variable or not, or one ordinal variable is depending on other nominal or other ordinal variable or not, we apply chi-square test. It is one of the non-parametric test. chi-square test हम करते हैं. तो chi-square test अप्लाई करने से पहले हमें क्रॉस tabulation करना होता है. Okay, so in this example what we can calculate the BMI category. We may calculate the BMI category of all the respondents, and we may check that is the BMI category is depending on location. That means BMI of rural background, BMI category is depending on location, because both the variables are, when we convert the BMI category into the BMI into different categories, then we may check that then this variable becomes nominal, or we can say ordinal variable, not nominal. What is the difference between nominal and ordinal variable? Nominal and ordinal variable. Anyone of you can tell me? Nominal means when we are giving the values or making the category only for identification. And ordinal means when we are making the category, when we are giving the values for categorization, identification, as well as the order is also meaningful. तो यहाँ पर हम कैटेगरी बनाएंगे 1 2 3. एक कैटेगरी क्या होगी? That is underweight, then normal, then overweight, then obesity. So to make the category of this BMI, which function we will use here? We will use here, because here there are more than two categories, so we will use here nested if. The function nested if equals to if function. That means if this condition will correct, then write this value, otherwise the next value. So if this value, so what are the BMI categories? First BMI category is that if the value is of BMI is less than 18.5 or 18.5, then we say that it is underweight. So we say that if this value is lesser than 18.5, then say underweight. Or otherwise, if it is only the two categories, we may write here the second category, but there are more than two categories here, so we will use nested if. That means अब दोबारा if condition लग जाएगी. If this value is greater than 18.5 but less than 25, then we say it is normal weight person. And if this value is less than 30, then it is overweight. And if it is not overweight, then it is obesity. Normal. Yes. Here we have, with the help of nested if function, we have formed the category of BMI. Now we are having the location, we are having the BMI category. So what we will do here, our objective is to find out that is the BMI category is depending on location, because both the variables, one is ordinal variable and another is nominal variable. So to check the dependency, we will apply the chi-square test. So here what we will do, we will first we will make a cross tabulation, and in last lecture we already discussed how to make cross tabulation with the help of pivot table. Okay, so here we are having the pivot table. On right side in row we will say location. In BMI category we will put in column and location in this. So we are having these values. So these are the observed values. These are observed values. Now to calculate the expected value, that means if the BMI category is not depending on location, then what will be your expected values? So to calculate the expected value, here we have note down the table only. Okay? We have copied the table, we are not copying the values here. So the formula for calculating the expected value is row total multiplied by the column total divided by the total number of observations. So for normal, the formula becomes equals to This is the row total. 1 minute. Here it is taking the, because we have prepared with the cross tabulation. What we will do here, we will make it values as values. Formula we will delete from formula. So what we will do, we will copy here and we will copy and values paste. Now this becomes only the values. Pivot table is, we have uh, copied only, the pasted only the values, not formula. So what the expected value for normal category and ruler background equals to sum of this particular row multiply by the sum of this particular column and divided by the total number of observations. Because we have to fix this total number of observation, we will function and F4. When we are clicking function on F4, the dollar will sign will be put it before the column and the row notation, and the cell will be fixed. The cell will be fixed here. Okay. This and function and F4. Now, in this row, we have to fix only the uh, row. So we will put the dollar sign before row, and here we have to fix only the column. So we'll put the dollar sign before column. Now, when we put the dollar sign in the cell location, then that particular location is fixed. If we are putting the dollar sign before the column, then the column is fixed. If we are putting the dollar sign before the row, then the row is fixed. So here, this is the expected value for ruler background person for normal. Now we will drag this function, and this function is copied here. So these are the expected values. Got it? These are the expected values, and these are the observed values. Now we have to apply the chi-square test here. So to apply the chi-square test, we'll say right equals chi-square, chi chi-square test. So the chi-square test returned the test for independence. This is for independence. Click here. Actual range. First we have to put the actual range. So this is the actual range. Then comma. The expected range. This is the expected range. Then close the bracket. Now the chi-square value for observed and expected is this. That means this is the chi-square value. If we have to calculate the p-value for this, what we will do? We will write equals to, then chi-square distribution, but we want the probability of right side, so we will set chi-square distribution right. X value is this, and degree of freedom is number of rows minus 1 multiply number of columns minus 1. So here the number of rows are 3, number of columns are 3, so 2 multiply 2, that is 4. Close the bracket. So the value p value is 0.96. So here in chi-square test, your null hypothesis that there's two variables are independent to each other. दोनों variables आपस में independent है, यानी कि obesity is not depending on location. And the alternate hypothesis that obesity is depending on location. So here p value is 0.96. That means greater than level of significance. That means we are fails to reject the null hypothesis. That means we are accepting the null hypothesis. So we will say that obesity, BMI category is not depending on location. Clear? That means null hypothesis यहाँ पर जो independence की null hypothesis थी वो accept हो गई है. but both the variables are independent to each other. Agar if this p value is lesser than 0.05, then we will say that the BMI category is depending on location. So I think this is sufficient for today. Revise it, and if there any problem, you may mail to me. If there any query, you may ask any participant.
Thank you very much, sir, for very informative and interactive session. And now I would like to request all participants, please ask your query. Simply raise your hand or write your query in the chat box.
Okay. Someone is asking to please share the worksheet of the practice. I will share this worksheet to with you, Amitji, and
Yes, definitely, sir.
please forward it to all the participants.
Yes, sir. I will forward this sheet to in the WhatsApp groups, all groups, and you will get from there.
Today only after 1 hour you will get this worksheet. No issue.
Yes.
Here formulas. Formula. Which formula? All formulas are in Excel. So you have to search in Excel only. Amitji, please share your email ID.
Yes, sir. I'm sharing my email ID. AMIT dot
Share to me only.
Yes,
On my
yes.
WhatsApp. On my WhatsApp. I will share you the.
Okay, sir. Okay, sir. All right, sir. All right. Dr. Hani, you can unmute yourself for query.
Namaste, sir.
Namaskar, ma'am.
Sir, can we calculate IC50 in Excel, sir?
Which? What?
IC50. IC50, sir. If we
For
are
what?
doing, in
Yeah.
case we are doing the inhibition of any like antimicrobial activity and we want to see different concentration, what is the amount of inhibition? So we do the IC50 calculation. So can we do that? Yes, sir.
No, there is no direct. We have to insert the formula for that.
Okay, sir. Okay.
You manually you have to insert the formula and do your calculation.
Okay, sir. Okay. Thank you, sir.
Welcome.
Yes, Dr. Asay.
Hello. Hello.
Yes,
Hello.
yes, yes.
Am I audible, sir? Hello. Hello.
Yes, Dr. Asay.
Yes, you are audible. Yes, yes.
Yeah. Okay. Good evening, sir. Very nice and interactive presentation was there. Actually, I just want to ask you. You asked to increase the level of significance in ANOVA. So how it is
Yes.
possible to if it is well defined that we should keep the level of significance to 0.5 level, but if we are
No, it,
increasing it to 0.05, so is it not going to create the error?
yeah. This is there are two types of error. One is type 1 error and type 2 error. If you are assuming that that type 1 error is not so harmful, you may increase it till 10%. It is not
Okay.
compulsory. It is not compulsory that you have to put it in only 0.055% only. When you
Okay.
are when you are feeling that is if the rejection of correct thing is more harmful,
Right. Got it.
then you
Got
have
it, sir.
then,
Got it,
then
sir.
you have to
Got it, sir.
reduce it.
Got it, sir. Got it, sir.
Okay, okay, thanks.
Thanks.
Then if there is any query, then please write your query in the chat box or simply raise your hand.
Okay, I think now
I
there is
think
no query.
Yes, sir. I think all queries are answered. I have left one mail ID, official mail ID. I think all participants know that mail ID. If
Okay,
there's any remaining query, then you can mail us in subject line. Please mention the name of our respected guest faculty or name of the session, so I can forward that query to our respected sir. I hope you enjoyed the practical session. From since last 2.5 months, we are learning concepts, and now from the Saturday we are applying practically. And we have 2 more sessions on practically using SPSS. Tomorrow we move on the session, one remaining session of descriptive statics, that is the measure of variability, will be delivered by Dr. Dharmendra Yadav sir. And after that, there are 2 sessions remaining in this whole program, which are using SPSS. Then we bind up this program and move to the test session. Thank you very much, sir, for
Thanks.
very interactive session.
Thanks a lot. I have saved this Excel sheet with all the analysis which we have done today. All the sheet 1 to sheet 12, 13 is there, and I am forwarding it to you. So
Okay,
you
sir.
may forward it. Okay, thanks a lot.
Definitely. Now, on the behalf of Institute of Applied Statics and the National Institute of Ayurveda Jaipur, we convey our sincere thanks to all the participants and our respected resource person of the session uh, for active participation and commitment for today's session. Now, this is the end of today's session. Tomorrow, we again start at 6 p.m. sharp. Now, there is one more important announcement for all participants that we are expanding this Ayurveda program in all over India day by day. For that, we need to connect more faculties with us, which are from Ayurveda background. So, on the behalf of Institute of Applied Statics, we requested to all faculties involved in this program to please share your detailed introduction or curriculum vitae with us on given mail ID ayurveda.is@gmail.com. So we can share these curriculum vitae to our management and for next program. So we can shortlist them according to assign for the chairperson and for the faculties at different modules. We are going to launch one program for Ayurveda specific professionals. So for that, we required more faculties from all over India. For that, you have that mail ID, ayurveda.is@gmail.com. Please share your detailed profile. So we present that profile with our management. Thank you. This is the end of today's session. Thank you very much.